Okay, welcome back. So what we're going to be looking at today is kind of doing the same things we do with numbers now for matrices, right? And so the very first thing we should talk about is equality, okay, or equals, right? Numbers are equal to each other. So for instance, like um, 2 squared, this is equal to the number 4, right? Because 2 squared is defined as 2 times 2, and 2 times 2 is defined as equal to 4, right? So we've got this, when we have numbers, an equal sign just means I have the same thing on both sides of the equation, right? And so for matrices, we want to now do that same thing, okay? And so to kind of demonstrate what equality would mean for a matrix, let's look at this example, okay? And then I'm wondering, should this be equal to a matrix like this, where everything is the same, it's just I have an extra column of zeros here, okay? So I'm wondering, here, maybe let me use a different color on the top here. Now this equal sign isn't necessarily warranted, okay? I'm just saying, should these two matrices be equal to each other, okay? And I mean, just looking at that, we're kind of like, well, I mean, I guess they have an equal part inside of them, but are they the exact same matrix? And no, they're not. These are not the same size. They're not even the same size, and then because this one has this extra column here, okay? So these we would say are not equal. To be equal, they need to be the exact same matrix, okay? So let's look at another example of this. So we've got 2, 0, 0, 1 in a matrix, and I'm wondering, is this equal to the matrix 1, 0, 0, 1? Okay, so is this equal? Are these two matrices, are they equal to each other? Okay, well, these two at least are the same size, so at least they have that in common, okay? But would we say that they're equal? Well, not really, because these have different, if you look, the corresponding entries, right? These guys line up. This 0 lines up with this 0, this 0 lines up with this 0. This 1 lines up with this 1, but this 2 and this 1, they don't line up with each other, okay? So this 2 and this 1 are not the same, and so we would say that these matrices, these are not equal, okay? So the entries, we sometimes call the things on the inside of the matrix the entries. Okay, so in order for a matrix, or sorry, two matrices to be equal to each other, what do we need to have then? They need to have the same size, first of all. Otherwise, they can't be equal at all. And then they also need to have the corresponding entries. So like this 2 is in the same position as this 1, so that those two need to be equal to each other, okay? So corresponding entries are equal. Oh, you can't see this. Let's squish this a little bit. Okay. There we go. Are equal. Okay? So, equal matrices have the same size and the corresponding entries are equal. Okay? So I'm going to do one example real fast of something that's kind of similar to one of the things on the homework. So the example is this. We've got a matrix, I'll say 1, 2, 3, 4. I'm wondering, is that equal, okay, to the matrix 2 to the 0, the square root of 2 squared, 3, and then 2 times 2. Sorry, running out of space here. Okay, so I'm wondering, are these two matrices equal? Let's move this because this is gonna get annoying. Sorry. Still running out of board space, even when I'm doing this over video. 1, 2, 3, 4. We're wondering, is that equal to 2 to the 0, 3, and then square root of 2 squared, and 2 times 2. Okay? So I'm wondering, are these two matrices equal to each other? So first of all, do they have the same size? Well, yes, this is there's 2 columns, 2 rows. This has 2 rows, 2 columns, right? So they are the same size. Now we just need to figure out, are the corresponding entries of these matrices equal? Okay, so these two are corresponding to each other. Is 1 equal to 2 to the 0 power? Well, this is one that you need to remember. This is, yes. Whenever you raise something to a 0 power, you get 1. Okay? What about 3 and 3? Yeah, 3 equals 3. So we're good. What about 2 and the square root of 2 squared? Is that true? When you square a square root, the square roots cancel, or sorry, the square root and the square cancel, so we just get 2. And so yes, this is true. And then 4 equals 2 times 2. Is that true? Yes. Okay, so these two matrices are equal to each other. Okay, so the matrices I don't think I spelled that right. Oh, yeah, I think it's okay. They are equal. Okay. So, how to check matrices are equal? They need to be the same size and have equal entries. Okay, so hopefully that helps.